Okay, we're starting with an investigation of arithmetic sequences, and we're going to talk about arithmetic and geometric sequences and different ways of writing them. I'm not going to lie, it's going to be both hard and easy as we go through this. It's a long chapter, and let's just start off real basic though. We're going to explore an arithmetic sequence. All right. So we're talking about a staircase, and each step is 7.5 inches, and it tells us there's 14 steps. And that gets us from the first floor to the second floor, and it says that total distance is 105 inches. So apparently 7.5 must go into 105 a certain number of times. And so they're going to give us two functions, b of s, that's the distance from the bottom, that makes sense, b of s, and t of s, which is the distance from the top. All right. So for both of those, the independent, what we're plugging in is s. And we can kind of see that located down here. And they started us off, right? They said, hey, when we haven't taken a step, we're still 105 feet from the top and we're 0 feet from the bottom. We've taken one step, two steps, we can see that our distance from the bottom increases. If I've taken 3 7.5 steps, it's increased even further. And if I've taken 4 7.5 steps, it's increased even further. Obviously 30 and 22.5. All right. Now the top is this. When I am approaching the top, obviously each one of those steps is reducing my distance. All right. That should be 92.5. So if I've come 2 steps closer to the top, right, I'm now 90. I should put 105 here, and I didn't. I did 100. Let's change that to 105 minus 2 times 7.5, which should get us about 1 times 7.5. So that should get us 97.5, and that'll work. And then if we've taken 3 steps towards the top, we're at 82.5. And if we've taken 4 7.5 steps towards the top, that gets us 75. So we can see as we get further away from the bottom, we get closer to the top. And obviously these two numbers right here are always going to add up to 105. All right. So there's a pattern. The pattern from the bottom is we start at 0. And every time we take a step, I'll just say the number of steps, right? I should put an S there, I guess, but I'll use N for right now. We get further away, and from the top, we start really far away, but our distance decreases as we take our number of steps. All right? So, and honestly, that's what's going to happen with these routines. We're going to have a start and a rule every single time, a start and a rule. Domain of this, well, the domain of this, there's a couple ways to write it, right? We could say our domain is just going to be the number of steps, which is going to be 0 all the way up to 14. They told us there's 14 steps. And our output, our range, right, is going to be 0, 7.5, add 7.5 every single time, all the way up to 105, right? And there's really nothing in between these. These are discrete points. We're not doing any fraction. You'll never see 0.5. You can't take half a step. You're either on a step or you're not. From the top, it's the same thing. My domain is going to be from 0, 1, 2, all the way to 14 steps. All right. My range is a little bit different, and we're going to show it different. We're gonna show that we're decreasing as we go through 97.5, 90, all the way down to 0. Let's just go ahead and do a quick graph of that. All right. At 14 steps and at 105, looks like these are scale of 10. At 0 steps, I'm at 0. 2 steps, I'm at 15. I'm just kind of making something that makes sense to me. Something that looks like this. Let's see if I'm correct. So 15, that should be 30, and that should be 45. Yeah, it looks like I'm right with 60 there. And something that looks like that. All right. And our steps down start at 105, which is right there, and after 14 steps we're at 0. And I might not be perfect with this, but I will give it a shot. And then we have kind of a graph that looks like that. All right. Now this is just talking about what they are. These are discrete points, right? Because the distance is changed by taking steps, right? And that's why we see this. Their graphs change with consistent discrete points. There is no straight line. You never take part of a step. And how are they different? Well, you know, from the bottom, B of S, right, is increasing. And the distance from the top is decreasing. All right, so let's go ahead and look at this next part. And we're going to pause here and post this. We can see the next part is actually talking about the general explicit recursive rules for an arithmetic sequence. We've done our kind of exploratory activity. And again, we're going to find out that this is just a starting point and then a rule. And specifically in this case, it looks like an addition rule. That's what an arithmetic sequence is. We'll continue that very soon.